I am now going to be presenting on interior and exterior angles. We know that a quadrilateral's total angle measure is always 360 degrees. We also know that all triangles' total angle measure is 180 degrees. My question is, what about a hexagon or a pentagon? What do their angles equal? Well, how many triangles are there in each shape? Because the number of triangles in each shape determines the value of total angle measure. For example, how many triangles can you fit in a triangle? 1. So you would do 1 times 180 to get the total angle measure. Now following that same pattern with a square, how many triangles can you fit in a square? 2. So we would do 2 times 180 to get the total angle measure, or 360 degrees. This means the number of triangles in a shape times 180 gives you the total angle measure of that shape. Sometimes it can be difficult to count the number of triangles in a shape, but if you do the number of sides minus 2, you will get the number of triangles in the shape. So the formula would be n, the number of sides, minus 2 times 180. Let's do an example with a square. There are 4 sides in a square. We would do 4 minus 2 times 180. So it would be 2 times 180 equals 360 degrees. And that is totally accurate. So now we are left with the formula n minus 2 times 180 equals total angle measure. Now for our example problem. We have a heptagon and instructions to find m. The first thing to do is to find total angle measure by doing 7 minus 2 times 180. So it would be 5 times 180 equals 900. Next, we are going to take all of the angle measures of the heptagon and set up an equation. Now I'm going to box all of my constants in blue and all of my variables in green. Then I simplify. Since we are doing reverse PEMDAS, I subtract 501 from both sides. Then you have 3m equals 399. And then you divide both sides by 3. Now we get the final answer, m equals 133. Next, we are going to discuss a real-world connection. Have you ever wondered what the total angle measure of a stop sign is? Well now, using our new formula, we can figure that out by doing 8 minus 2 times 180. Now we are going to do some examples of angles and where you can find them in real life. Like this window, for example, you have 90-degree angles as well as perpendicular angles. Another example are these roads here. They are an example of transversal angles. You can see that because the vertical angle is cutting the horizontal angles. Thanks for watching! Don't get it twisted. It's fun to stay at the YMCA. Na, 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 na. The light, what time is it?